All right, cofunction identities. All this means is that no matter what these angles are, if this is 30, then this has to be 60, right? If this is 20, then this has to be 70. If this is 10, then this has to be 80. If this is 45, then 45. So it doesn't matter what it is. All you're doing is subtracting from 90 to get it. And then the relationship. Notice that the sine of theta here is A over B, right? A over B, where the cosine of 90 minus theta, this is going to be this side. Cosine is adjacent. I said A over B, sorry. Let me back up. That should have been A over C, right? So this one's going to be from here, adjacent over hypotenuse, A over C. So looking at different angles using the different cofunctions, you'll notice sine and cosine go together. Tangent and cotangent. Secant and cosecant. So they're always the cofunctions, pretty easy to identify. And it doesn't matter whether it's 90 degrees or pi over 2 down here, right? 90 or pi over 2. Once you have that relationship figured out, then we got to find cofunctions of the same value. Well, the sine is equal to the cosine of 90 minus 46, or the cosine of, what is 90 minus 46? That's going to be 44 degrees. Clearly those two, 44 and 46, have to add up to 90, don't they? For cotangents, the cofunction is going to be the tangent of pi over 2 minus pi over 12, or tangent of 6 pi over 12 minus pi over 12 gives me the tangent of 5 pi over 12. Cofunction identities. Couple of concepts for word problems. Anytime you have a line of sight, the angle of elevation will always be looking up. The angle of depression will always be looking down. The right triangle, depending on where you're going to be, is here or here or here. Pay attention to it. If it's angle of depression, quite often you'll notice that because of a rectangle, alternate interior angles are congruent, so these two angles will be congruent. But pay attention to what's given to you. This would be considered the angle of elevation, looking up, if I'm looking up from the car. From the airplane, this would be the angle of depression, which would be the same as the angle of elevation here. Those would be equal, wouldn't they? All right. So, a regular blue shape in figure 4.39 represents the lake. The distance across the lake A is unknown. To find this distance, the surveyor took the measurements shown in the figure. What is the distance across the lake? So we have a trig problem here, where we're told that this angle is 24. We are looking for the side opposite. We have the side adjacent. Opposite and adjacent, wait a minute, SOHCAHTOA, that would be a TOA, right? Tangent, opposite and adjacent. So tangent of 24 is equal to A over 750. This is a proportion. And again, you can use your calculator now. This is where you pick up your calculator, make sure you check your mode. Make sure your mode is in degrees now. And you guys, anytime you pick up your calculator, check your mode. So, before you plug this into your calculator, solve for A. Cross multiply and solve. We get A equals 750 times the tangent of 24 degrees. Or 333.92. We would probably just say this is 334 feet, yards. All right, our last problem. A flagpole is 14 meters tall. It casts a shadow 10 meters long. Find the angle of elevation of the sun. So it's real simple here. You guys draw a picture. Here's your flagpole. Here's your shadow. Your sun, is shining from up here someplace, right? So that's going to cast or create a triangle like this. 14 meters, 10 meters, right angle. Find the angle of elevation to the sun. This would be your angle of elevation. Using SOHCAHTOA, this looks like opposite and adjacent. So TOA means tangent of E, the angle of elevation, equals 14 over 10. Something new, right? Okay, so when you rewrite this, rewrite it as the inverse tangent of 14 over 10, and you can reduce that if you want, equals E. And again, we're going to be in degrees. Make sure you check your mode. And when you plug this in, it's going to be second function. There's a button on your calculator. It's a second function tangent, which will activate the inverse tangent. Okay? And right above the tangent is that inverse tangent button. Plug it in and you end up with E, whatever that angle is, equals 54.46 to the nearest degree, so we're going to go ahead and say this is just 54 degrees, right? You round, that 6 doesn't matter, so you round 54 degrees is your answer.